So, all right, the recording has started. So, we will start our session in a regular way. You can see my slides. I will start the session. So, welcome everyone. This is Zahid Bashir, your trainer for SPSS data analysis. So far, we have completed our basic level and we have covered a lot of contents using the basic level, like the awareness regarding some basic tools, and as well as we have also done how we can compute our variable, how we can analyze our descriptive statistic, including cross tabulation, how can we check the reliability of data. And we have also done in our previous session on that was held on Friday. We have completed our detailed discussion along with the SPSS procedure for mean comparison of two groups and more than two groups. And before that, we have also done the mean comparison in detail for one group standardization comparison. So today we are going to start the intermediate part of quantitative primary data analysis using SPSS 27. So here comes the contents or the topic that we will cover today. Our first session will comprise 6 p.m. to 7 p.m. Mastering the bivariate correlation analysis. And one thing I would like to let you know that there will be a 10 minutes break between 6:40 to you can say sorry 6 35 to 6:45. There will be a 10 minutes break where you can take tea, you can drink water, or you may relax for 10 minutes. You can perform your activity of analyzing your exercise drill that I will provide. I have also shared the data set for today's session that I will let you know how to use them. So in session 2, we would cover the mastering regression analysis. How will we analyze the simple and multiple regression, and how will we report them? How will we interpret them? Then we will test the assumptions of the regression analysis. So what are the assumptions and how we could test them in SPSS 27? So it would be the session third part. So in each session there will be a 10 minutes break. In the first session we will have a 10 minutes break between 6:35 to 6:45. Then we will have a 10 minutes break in you can say in 7:35 to 7:45. Then we will have a 10 minutes break in 8:35 to 8:45. So these are 10 minutes break where you can relax and you can make yourself comfortable for a 10 minutes to make you active for the next part. So let us start from the bivariate correlation analysis, which is the part of session 1. So what we cover in bivariate correlation analysis, we will cover what is the definition, what is the purpose, and how do we apply the bivariate correlation analysis. Then I would let you know the types of bivariate correlation analysis, whether it is positive, negative, and zero, and it would be helpful for our interpretation also. Then I would let you know the assumptions of correlation analysis, Pearson correlation, definition, range analysis, reporting, and interpretation. This would be the first parametric correlation analysis, which is known as Pearson correlation analysis. Then we would move forward towards Spearman rank correlation, where we need to understand the definition, range, analysis, reporting, and interpretation. Then we would go towards the partial correlation, why we use it, what is the definition, what is the range, and how we can report it. So this is basically the contents of our session 1, which is on bivariate correlation analysis. What is correlation analysis? First, we need to understand the definition. The word correlation originate from Latin word correlatio, where core means together and relation means the relation or connection. So when we want to find out the statistical relationship or the degree and the nature of relationship between two or more variables, we are referring towards the correlation. It reflects how changes in one variable are associated with changes in another variable, providing a measure of the strength and direction of their connection. So this is basically the basic idea of correlation, that we might be interested in finding out whether one variable is positively related, negatively related, or there is no relation of that one variable with another variable. So how can we do it? We can do it with the correlation. So when we study the correlation between two interval or ratio scale variable, uh, first thing you need to understand that our type of variable would be interval or ratio scale. If you can see the different correlation technique, like in Pearson correlation, we need to use the interval, ratio, or continuous variable for the purpose of correlation. But if we have basically the ordinal variable that need to be correlated, we need to use Spearman rank correlation. So the type of variable is basically very important. If your variables that you want to correlate are continuous variable, or they are basically, you can say, the interval or ratio scale variable, you need to use Pearson correlation. But if your variables are ordinal variables, they are showing some order, and you need to check their correlation, then you need to use Spearman rank correlation. While there is another logic of partial correlation, when you need to provide another covariate in your correlation, you can use it partial correlation. The detailed explanation, the definition, and other things, other text that is related with partial correlation will come on the next of some slides. So you need not to be worried about their definition or explanation. So I was telling you about the basic definition of correlation, where I have told you that it is the relationship between two variables. One might be dependent, one might be independent, or both. They may both be our independent variables. So what we need to do in order to check the relationship between two interval or ratio scale variables, we need to start with scatter diagram. If you remember, when I was giving a session on different types of diagrams and charts, I have told you about a scatter diagram. That is the graphical representation between two variables. So when you want to analyze the relationship between two variables, first you need to check whether the graphical representation showing a positive relationship, a negative relationship, or something else. So you need to analyze the data using scatter diagram first. Then you need to understand what is correlation analysis, a group of technique to measure the relationship between two variables. Uh, the usual first step is to plot the data in scatter diagram, as I have told you right now, that as a first part, you need to find out the scatter diagram graphically. You need to check whether it is a positive relationship or negative relationship, or there is no relationship between the variables. So scatter diagram will let you know about the direction. The second step is that you need to find out the correlation coefficient using Pearson or Spearman method. So if your variables are continuous, means, interval, or ratio scales, you can use Pearson correlation. But if your variables are in ordinal, it is showing some order, you need to check it through Spearman method. So, what is correlation analysis? Correlation analysis includes both steps. As a step one, you need to find out the scatter diagram. As a second step, you need to find out the correlation coefficient. So, how can we define the correlation coefficient? It is a quantitative measure to represent the association or relationship between two variables. So, when we want to find out the quantitative measure of the association between variables, we need to find out the correlation coefficient. But if quantitative measure is not required, scatter diagram would be enough to find out the correlation. So correlation coefficient represent the quantitative measure. In other words, it quantifies the strength and direction of a linear relationship between two numerical variables. The correlation coefficient, often denoted by R, ranges from -1 to +1. So whenever we need to interpret the correlation coefficient, it is denoted by small r, the alphabetical small r, we basically use for correlation coefficient. What is the purpose of correlation analysis? The first purpose of correlation analysis is to quantify the relationship between variables. So when you need to quantify the strength and direction of relationship between two or more variables, this provides a numerical measure of how changes in one variable correspond to changes in another. The second purpose of correlation analysis is basically uh, correlation analysis helps to quantify the strength and direction of relationship between two or more variables. This provides a numerical measure of how changes in one variable correspond to changes in another. The next purpose is predictive power. Understanding the correlation between variable can provide insight into the predictive power of one variable based on the other. So if there is a strong correlation, it may be possible to predict the value of one variable given the value of another. The third purpose is basically identifying the pattern. Correlation analysis helps identify pattern and trend in data. For example, a positive correlation suggests that one variable increases, the other tend to increase as well, while a negative correlation implies an inverse relationship. If one increases, the other may decrease. So we can identify the pattern. That is very important. The fourth purpose may be research and hypothesis testing. Researcher use correlation analysis to test hypothesis and explore relationship between variable. It helps in investigating whether there is a statistically significant association between the variables under study. Uh, Next purpose might be variable selection. In fields like economics and finance, correlation analysis is used to select relevant variable for models. It helps identify which variable are more strongly related to phenomena being studied. So whenever you wanted to select some variable for your regression analysis or for further analysis, you may identify which variable are important through correlation analysis. Quality of data may also be checked using uh, correlation analysis. Correlation analysis can be used to assess the quality of data. If unexpected or unexplained correlation are found, it may indicate issues with data collection or the presence of confounding variable, which is considered as a mediating or moderating variable inclusion. You may also need the correlation analysis for further decision making. In business and management, understanding the correlation can aid in decision making. For example, a company might analyze the correlation between advertising spending and sales to optimize marketing strategy. And last thing, but not the least thing, it is important to note that correlation does not imply causation. Causation is basically regression. You cannot predict here the impact of one variable on another. You just need to see whether two variables are related in a positive way, in a negative way, or there is no relationship. But it does not imply the causation. While correlated variable may show a statistical association, it does not necessarily mean that one variable causes the other to change. Careful interpretation and consideration of one factor are essential when drawing conclusion based on correlation analysis. So here comes the application of correlation analysis in the healthcare domain. Considering the correlation exercise habits with heart health, whether you want to know whether the habits and heart health are correlated in a positive way, in a negative way, or there is no correlation between them. So researcher may investigate the correlation between regular exercise and cardiovascular health to provide insight into preventive measures and health recommendations. So if you are interested whether uh, doing the regular exercise would decrease the heart attack rate, you may be interested in correlation analysis. The next thing that you may be interested in education domain, that correlating students attendance with their academic performance. Educators might analyze whether there is a correlation between consistent attendance and higher academic achievement to identify the factor influencing the student success. You may also be interested in psychology domain in order to find out whether sleep patterns is associated with mental health. So psychologists may explore the correlation between sleep quality and mental health condition to better understand the relationship between sleep and emotional well-being. You may be interested in finance and economy domain, where you would like to find out the performance of different stocks, and you would like to correlate the stocks of different companies to find out whether there is a positive correlation, there is a negative correlation, or there is no correlation. This would be helpful in analyzing the risk factor. If both stocks are correlated in a positive way, it means high risk is involved. If one goes to the loss side, the other will also go to the loss side, and if one goes to the profit side, the other would also go to the profit side. So in finance and economics domain, uh, correlation is very helpful in deciding whether there is a risk involved or not. Then you may be interested in market research, whether you are interested in analyzing advertisement spending with sales revenue. So if increasing the advertisement increases the sales revenue or not. So companies may explore the correlation between their advertising investment and resulting sales to optimize marketing strategies and budget allocation. So, last but not the least, that is environmental studies. You may be interested in correlating the pollution level with respiratory disease. You may be interested as a environmental scientist to analyze the correlation between air or water pollution and prevalence of respiratory diseases in a particular region to assess environmental impact on public health. There are three types of correlation. The first one is positive correlation. A positive correlation exists when an increase in one variable is associated with an increase in the other, and a decrease in one variable is associated with a decrease in other. You can see this picture, the graphical representation, and you can see that a line or the pattern start from the left side, and it goes upward on the right side. So when a pattern is giving the visual like this, it is starting from the left side downward, and then it goes upward on the right side, it is a positive correlation. So whenever one variable on the y-axis and one variable on the x-axis are analyzed or correlated using the scatter diagram. I will show you the SPSS procedure. How can we determine whether there is a positive correlation, there is a negative correlation, there is no correlation. using the SPSS graphical function using scatter diagram. So here you need to identify whenever there is a pattern which starts from the left side, from the down point of the left side, and it goes upward on the right side, it will indicate the positive correlation. So the correlation coefficient R is positive, ranging from 0 to +1. A correlation coefficient of +1 indicates a perfect positive correlation where the variable move in the perfect tandem. The next one is negative correlation. Whenever you see that uh, the pattern start from the left side, on the top position of the left side, and it goes downward on the right side, it is negative correlation. So whenever I would prepare the scatter diagram, and if you find the pattern like this, that the dots are moving from left to right downward, it is a negative correlation. So what we call it, a negative correlation occurs when an increase in one variable is associated with a decrease in other. So there is an inverse relationship between both variable. One variable might increase and the other variable might decrease, so a decreasing pattern will show you. So the correlation coefficient is negative, ranging from 0 to -1. So a correlation coefficient of -1 indicates a perfect negative correlation where the variable move in opposite direction in perfect proportion. The third one, the third type is zero correlation, where you cannot identify any pattern. You cannot decide here whether it is positive, whether it is negative. So if you cannot identify any specific pattern, it will be considered as zero correlation. So a zero correlation means that there is no linear relationship between two variables. Changes in one variable are not associated with changes in other. So we cannot identify that average exam score may increase or decrease the height in inches, or height in inches may increase or decrease the average exam scores. This happens often when you want to relate some variables which are theoretically are not related with each other. So whenever you are whenever you are trying to relate the variables which are not theoretically or logically related, this situation may happens that a zero correlation will occur. So a zero correlation means that there is no linear relationship between two variables. Changes in one variable are not associated with changes in other. The correlation coefficient is close to zero. It doesn't mean zero, it may be close to zero. So whenever the correlation coefficient is close to zero, we may consider it a zero correlation. A correlation coefficient of zero suggests no linear association, but it does not necessarily mean there is no relationship between variable. There may be non-linear or more complex relationship. So there are other techniques when there is no linear relationship. We need to check it from non-linear technique like Spearman rank, or there is another technique which is main as Kundal Tau B technique. I will let you know in during the SPSS process. There is another category which is considered as monotonic relationship. What does it mean? A monotonic relationship is a mathematical concept that describe the consistent direction of association between two variable. In monotonic relationship, as value of one variable increase or decrease, the value of other variable consistently either increase or decrease, but not necessarily at a constant rate. So when there is no when the other value increase or decrease but not at a constant rate, we would consider it as a monotonic relationship. In other words, there is a systematic trend in the relationship, but it does not have strictly linear. So when the condition of linearity basically violated, we may consider it as a monotonic relationship. Like you can see here, there are some dots which are in the start level, they are separate from each other, but as you increase the slope, they come closer. So it means in the starting level, there is a rate of change, there is a more rate of change between them, but when you increase the number of observation, there may be a less rate of change. So as the definition or the explanation also indicates that there may be no constant rate of change. There may not be a necessarily at a constant rate of change afterward. It may becomes the monotonic, like you can see over the other example, which is negative, but it is also showing a monotonic relationship. At the start there is a rate of change, but after more number of observation, it comes closer. So the gap basically come closer in afterwards. So this is also monotonic relationship. While if the relationships become parabola or the shape like this, it will be a non monotonic relationship also. So there is another technique which is known as Kundal tau b technique, which I will use for a monotonic relationship if it is found using a scatter diagram. This is basically the interpretation guideline that we will use during our SPSS procedure. You need to understand how we can interpret the value of correlation analysis. So if correlation is zero or close to zero, if a correlation is zero or close to zero, we may interpret that type of relationship as a no correlation, or there is no correlation between two variables or between variable 1 and variable 2. So if the correlation coefficient is 0 or close to 0, but if the value is between 0 to positive 0.50, if the value of correlation is between 0 and 0.50 on the positive side, on the right side, it means a weak positive correlation. So when we interpret the correlation coefficient, we need to identify if the correlation coefficient is between 0 to 0.50. We may consider it a weak positive correlation. In the same way, if the value of correlation coefficient is between 0 to minus 0.50, we may consider it a weak negative correlation. In the same way, if the value is exactly 0.50, we may consider it a moderate positive correlation. In the same way, you can say if the value is exactly minus 0.50, it becomes moderate negative correlation. Uh, Similarly, if we find a value between 0.50 and 1.00, it would be considered as a strong positive correlation. And if we find a value equal to 1.00, it will be a perfect positive correlation. On the same way, on the left side, if you find a minus value between 0.50 and minus 100, you may consider it as a strong negative correlation. And in the same way, if you find a value equal to minus 100, it will be perfect negative correlation. So in this way, whenever we compute the correlation coefficient, we need to interpret using these words that were stated above your different values. So the sample correlation coefficient is identify the lowercase r. Whenever we need to interpret the correlation coefficient, we will use the small r from the alphabet as a correlation coefficient. It shows the direction and strength of the linear relationship between two interval or ratio scale variable. One thing you let to understand that whenever you are going to analyze the linear relationship, and whenever you going to analyze the data with uh, continuous variable, it means interval or ratio scale variable. You are going to use the you are going to use the Pearson correlation. The other category is Spearman rank correlation, which is useful whenever you are going to analyze your data with ordinal variable. So it ranges from -1 up to n including +1. A value near zero, a value near zero indicates there is a little linear relationship between the variable. A value near 1 indicates a direct or positive linear relationship between the variable. A value near -1 indicates an inverse or negative linear relationship between the variables. So these were the basics to understand that how would we analyze our data. Next is the assumption, and after the assumption, we would see the example one, and I would let you know that which variable from example one we are going to test. So first assumption is linearity. There should be a linear relationship between the variables. This is the first assumption. This means that a straight line can adequately represent the trend in the scatter plot of the data. So whenever we are going to estimate the correlation of two variables, we first need to find out the scatter diagram, whether there is a linear trend or not. So if the relationship is non-linear, correlation coefficient may not accurately reflect the association. So in case if we find out that there is no linear relationship, we may apply a different method, like Kundal-Stauve method is a non-linear or non-monotonic relationship. The next thing is homoscedasticity. Homoscedasticity is refers to the assumption that the variability of the residual, the difference between observed and predicted value. Basically, the data set given to us is the observed values, and when we estimate some values as a predicted value, we need to see whether there is a difference between observed and predicted value, and it is constant across all level of independent variables. So in other words, the spread of the data points should be roughly the same throughout the range of values for both variable. So I will let you know after some slides that how it can be checked. Normality is also a bigger concern when we are analyzing the correlation or regression. While correlation analysis does not require the data to be normally distributed, it is sensitive to extreme outliers. So if there are some outliers in your data, then it may indicate that your data is not normal. So outliers can disproportionately influence the correlation coefficient, potentially leading to inaccurate conclusion. Removing or addressing outlier may be necessary in some cases. So if you want to analyze the correlation analysis between two variables and both are important, but after analysis it was revealed to you that there is no correlation between the variables, you need to check whether your data has some outliers issue, or you may not have confirmed the normality of the data. So if there is a case of normality or outliers in your data, your result may be different as compared to your expected results. Independence, the observation should be independent of each other. It means those two variables you are going to analyze must be independent from each other. The value of one variable should not be dependent on the value of the other variable. So if they are dependent with each other, or the observations or the data are dependent on each other in case of both variable, the assumption may be violated. This means that the value of one data point should not depend or not influenced by the value of another. In time series data, for example, serial correlation or autocorrelation should be considered. Interval or ratio scale data, as I have already told you, that we are going to use most preferably both variable as a continuous variable or ratio scale variable. So correlation analysis is most appropriate for variable measured on an interval or ratio scale data. This assumption ensures that the numerical value represent the equal interval between points and have a meaningful 0 point. Next is perfect correlation, no perfect correlation. This is basically the ideal stage. If you find a value equal to +1 or -1, it indicates the perfect correlation. Correlation analysis assume that there is no perfect correlation. Correlation coefficient of +1 or -1 between variable unless they are perfectly correlated for a specific reason. So if both of the variable are perfectly correlated, it means they are giving either the exactly +1 value or either they are giving exactly the -1 value. We need to find out the specific reason why they are perfectly correlated. So most preferred values of correlation should be between 0 and 1. It may be between 0 to +1 or between 0 to -1, but not exactly +1 or -1. So if they are exactly +1 or -1, we need to find out the specific reason why they are perfectly correlated. So a perfect correlation may indicate redundancy or a problem with the data. So you need to identify whether your data has some problem or not. So the last two assumptions are no causation inference. You cannot conclude that both variable cause each other. Correlation does not imply causation. Even if a strong correlation is observed between two variable, it does not necessarily mean that changes in one variable cause changes in other. So causation is basically related with regression, not correlation. So you cannot decide over here that if two variables are correlated and significant, they may cause each other. Appropriate data distribution, your data need to be appropriately distributed. The session would be going to end within a minute. Please join using the same link. If the session will be going to end, you need to join using the same link that I have provided in your WhatsApp group. So next is basically the difference between Pearson and Spearman correlation that I will let you know.